Okay, so let's get started. Um, Hi everyone, and thanks for joining this month's cadCAD community call. Um, we have a few things on the agenda. First of all, we're going to give a few updates on what we have been working on, and a few questions and discussions maybe around them. And finally, we have um, Frazier from BlockScience that's going to talk about the labs platform, but more on that later. We're going to start with the infra and education working group. So first, we started working on a wiki, and I'd like to invite everyone to collaborate with any kind of important resource or relevant resource. So essentially, make we can make it a place where anyone wanting to navigate cadCAD better can get some help. Then on the community calls, so we used to have two rotating times. So one month would be for North America slash Europe, and the other month would be for the APAC time zone. So we decided that we are better off just having the North America time. So from now on, all community calls will be the first Wednesday of each month, 6 p.m. UTC. And finally, the study group that's with in collaboration with the Token Engineering Academy is still running. Quiet Catalyst and CC Star are working on a new structure based on 2-week sprints, which I believe started yesterday. So anyone that's interested in hacking together cadCAD should jump over to the T server and join the study group. Now we'll go over some core tech updates. That's Chris is going to help me here. So.
Hey, Anthony, your stream is not showing.
Yeah, I'm gonna stream the
No.
the presentation for my section.
Okay, sorry. Are you sharing already? Oh, it seems like it's.
We've completed spaces. It basically represents 25% of most of the cadCAD development. We're currently working on blocks and points. That represent another half. The sort of architectural origins of this is totally different than the current production version of cadCAD. After blocks and points, we're going to be working on a DAG of blocks, then trajectories. We're thinking it's likely a class. And after those two pieces, you'll be able to run and execute models. And after the ability to execute models, we'll start working on experiment tools. You can check out the repo at cadcad.org/cadcadri for reference and notation. One of the things I just sort of want to note here is we actually went through multiple iterations of spaces, blocks, points implemented, and what we found was that they weren't quite satisfying the initial sort of goal of this whole project, which was to increase legibility of the modeling, to ease the onboarding, and to add more modularity. And what we found was that on this current track, we had to almost hybridize concepts from functional and objective programming, even blending notions of types and classes, which I'll get to in a little bit when I talk about what we've done on spaces. And this has enabled us to really express concepts from generalized dynamical systems, which is the conceptual underpinning of cadCAD, in the software, and have the software sort of embody the ontology and structure thereof, which is really what we've seen as the central tension right now for people using cadCAD, whereas like the software is not really expressing the concepts. So we made the decision to basically blow out our original timelines to do this the right way, and we're really excited with what we've done so far. So what we've solved was, for spaces, we basically hybridized types and classes. So spaces now are a decorator. They digest a Python class, and it augments Python classes with functionality for spaces to work in the way intended as part of generalized dynamical systems. So when you multiply in some types, it's not on objects, and this enables you to produce new types as a result. So you get basically a class factory of space types. And we're able to overload operators in this way. So you're using familiar symbols, and you can now do Cartesian products, summations, powers. And what this really enables is simplified UX for building the models in digital twins. You still have familiar operator symbols. It's got a set theory-like behavior to it. And you're constructing spaces through decorators and composition of spaces, so you get a little bit of that modularity going on there. It's very similar to defining data classes in Python, and we see this as enabling faster development because now you get type safety, so you get your runtime checks, you get static analysis checks, all included in there, which is not something you can really do right now, the current version of cadCAD. Other really nice thing is we can add new behaviors to space types without breaking changes. We're very well aware that breaking changes has been a development and production release pattern that is something we've not wanted to continue, and actually that's what kicked off the consideration of re-architecting cadCAD. Our current challenges, we're almost basically done on signature of block functions. We just have to come to a decision on it. The nice thing about this is it reduces code complexity, maintenance, and the likelihood of bugs. So you get a little bit more code stability. The signature is the types of both the arguments and the return. And one signature gives us predictability when transforming callables inside of the decorators that we're making heavy use of. So it's basically the team has to just sort of check that off, and then we'll call that one done. We also want to use blocks as decorators, as the way we've done with spaces. Now we're extending that to blocks. Something that was important to us as we were developing was we needed to get spaces right, and then that sort of flows into blocks and then points and everything else. So we're sort of reusing the same design patterns as much as possible, again, for that like legibility and ease of onboarding. If you get the pattern, it sort of just keeps extending along the way. And this will enable us to reduce the amount of boilerplate. Like right now in the cadCAD models, there's a lot of cruft. We're aware of it. So we want to reduce boilerplate as much as possible, make the code legible. The next challenge is providing strong mathematical formalisms for the algebra of spaces. This is more of sort of complying with the spec of generalized dynamical systems and giving people confidence that there's correctness in the way that spaces get manipulated. We're thinking it's likely category theory, but it's kind of TBD. It's work in progress at the moment. Last but not least is points as a specializable type through singular space in a given model. This will give us more legibility into how blocks are constructed and type safety when running the model. So we're looking at enabling explicitly defining the relationships between a point and a space, and this also allows you to check it during runtime and static analysis. And these spaces can be user-defined or just an inbuilt space. And last but not least is future design challenges is thinking about how do we do a pipeline of blocks. We're thinking it's probably a visual language to be able to take a line of blocks and concatenate them as DAGs. Probably use like greater than and pipe operator symbols. The cool thing about this is it ties in really nicely to visual cadCAD. I don't know if you've seen it. There was a sort of a teaser video shared on visual cadCAD, which is a GUI-based model builder that BlockScience Labs is building. And we think that that's really going to enable a lot more people to onboard to cadCAD, start their model building journey, which is where the whole cadCAD reference journey started, which was we want more people to be able to start their model building journey, and if they want to graduate to more complex implementations, they can so do so, or if they're focusing on different tracks of work, they still have the basics and fundamentals there. So before I hand it off to Chris Frazier, any questions or comments? I'm going to assume we're all good. Cool. All right. And now I'll hand it off to Chris Frazier.
Thank you. All right. Set up screen sharing. I'm going to do window. Is everyone able to see a presentation?
I got it, Chris.
Sweet. All right. So, hi everyone. I'm Chris Frazier. I'm the CEO of BlockScience Labs. I'm going to do a really quick presentation, and then I'll dive into a demo of the platform. So if you don't know who we are, BlockScience Labs was incubated by BlockScience, which is an R&D firm, with the idea that we were going to productize the engineering principles that BlockScience is well known for. And we're very much focused on creating a collaborative space where people can work together on the type of work like we were just talking about, what you would do with cadCAD, and really have an easy way of sharing the insights that you develop through this analytical work that you're either doing for your own research or that you're doing with some collaborators. And so our vision is that the platform is going to allow for this iterative work and guide you through the process of how best to approach this kind of work, so that you can really make sure that you have all of your documentation, your design specs, your model, the code, and then be able to publish your documents or your models publicly or privately, but really have it be a single source of truth, so that anybody who wants to have visibility into what's going on would be able to log in and see this. Because that's a real pain point that people have, where you have these requests, you are working with an analytical team, but maybe you don't really have visibility into the progress that's happening. And there's a real need there for you to have easy access to log in and not only have visibility into what's happening, but also be able to participate. So we want to make that easier as well. But we want to make sure that we are following this vision that we're all acting upon. And there was this great tweet that Brian Peets had sent out, where he showed these two videos, which was basically, one was a video of a tool shed and one was a video of a Swiss Army knife, where the idea is that, you know, what he was looking for is really the idea of a tool shed where it's really a collection of all the tools that you need to do your job. But what we don't want is to have some sort of Swiss Army knife where you're just trying to replace everything that people do. And this is really matching the vision that we have at Labs. We want it to be where we have options for you for tooling that we'll provide, but it's really more an integration hub where you're able to use tools that we provide, but also integrate with the other tools of your choice and really have it be the one place where it's connecting to where everything is housed. So what I wanted to do was jump into a demo that I'm really going to touch on 3 main points. I'm going to first walk through just getting onto the platform, creating a project, and being able to add collaborators. Then I'll move into running a cadCAD simulation. It's using 4.27 and 4.28, so I'll show you how that works, where you can run a simulation and then actually take those results and work with them. And then finally, I'm going to cover the publishing, being able to create a doc site, and showing or sharing your smart papers. And I'll pause in between these 3 sections for questions in case anything comes up. So I'm going to switch over to the platform. I just want to make sure, can you now see I've switched over to the Labs platform?
Yep, can see it.
Perfect. So I'm going to first log out because I want to show you from the beginning. So when you first come in, the sign-up process we tried to make as easy as possible. So when you come into here, you can just, I'm just going to create a test account just to show you the steps and how easy it is. We'll call this test plus test 4. You can put in some password. This is probably the most difficult part, is coming up with a good password. And it does guide you on what's required for the password, but it's the basic stuff: a capital letter, number, you know, special character. And then they'll have a SaaS agreement, which is basically saying, you know, this is software as a service. You can agree to that. You can also download it if you want to have a copy of that in PDF. And then the third step, which is optional, but it's important, is connecting to GitHub. So I'm just going to go ahead and connect to show. This automatically did it because I'm already connected on a different account. But basically what it does is it takes you into GitHub and it says, will you authorize BlockScience Labs to connect? And this is important because we're using GitHub to pull in the repos to create projects. If I click finish, it'll take me back to the sign-up screen, or the sign-in screen. And then I'm actually gonna, I don't want to log in with this one. I want to log in with my regular account, so there's more interesting stuff there. But once you've actually created your account, then the next thing you're going to want to do, if you hadn't connected to GitHub, you'll want to do that here. But you're going to want to also throw in a credit card. Now, we don't, there's open access to the platform. We're not charging just to use the platform as is. The first thing you'll need to add a credit card for is for white labeling, so that you can access the Jupyter Lab and also be able to run simulations. So adding a credit card doesn't mean we're going to start charging it. There will be subscriptions being offered on the platform to have some enhanced services, but our intention is to have this be an open core product where a lot of the things I'm showing you today are going to stay free, and then we're going to be offering you services that we think you will find useful for doing extra work within this. So that's adding the credit card. So now that I've entered into the platform, I want to work with some collaborators. And so if you're looking at this list, this is just a bunch of projects that I created, but a project is basically a container for collaborative work. And if I was to go and create a new project, since I connected this to my GitHub repository, I now have all of the ones I'm in two. I'm in BlockScience Labs and myself, personal one. I can now take one of these and pull it into the platform. And let's just say, I'll just call this test. Give it a name, create, and then now I have a new project here that's empty, but it's an empty container for doing some collaborative work. And what I'm going to want to do first is really add some people that I want to work with. So in this example, I have this model that I'm going to be going through a little bit more. But we have the permissions tab where, in this case, I've already invited several people to this project. And if I wanted to add another person to work with on this project, I would just click on the Add Collaborator. As of this moment, they're required to have already created their own accounts. But we're working on right now creating a very easy invite process. So they'll actually get an email and it'll invite them to join the platform if they're not already part of the platform. We're also working on enhancing the permissions. So right now, everybody has equal permissions within the project, But the one thing that's nice about this is that I'm able to invite people to work on this project with me without requiring them to be part of my GitHub repo. So none of these people necessarily have access to my GitHub repo. This is all being handled through Labs. And so now that I've invited them here, we can collaborate on work here without me having to give access to a repo. And I can keep my GitHub repo private if I want to, and only really have the interaction happening in the Labs platform. So that's the first section of signing up for the platform, adding a credit card so that you're white labeled, and then adding collaborators. Is there any questions on what I just went over, or else I'll move on? Great. So then what I want to go over is actually running a simulation and then pulling that data in. So I've run a bunch of simulations here, but I'm just going to run a new one. So basically what we've done is we created our own cloud infrastructure on AWS to allow for you to run your cadCAD models in a more scalable environment. And so what happens is that when you're going through these steps, it is creating a new virtual environment in our AWS infrastructure. It's installing cadCAD, it's installing a couple other packages, and it's doing a check on your code. Because what it wants to do is find the system model that you've named. And I'm going to show you where I named this one in case you haven't seen how to do that before. And it's also making sure that you have a labs.py, which basically tells our platform where it's located. And so because I have the labs.py, I was able to find it. And the last step, what it does is it tells you how much it will cost to run on our cloud infrastructure. Our rate is 50 cents per computational minute. This is a very short model, so it's giving a really quick estimate because it's just basically running one Monte Carlo run. And I'm going to be using credits to pay for this. But when I click execute, what you'll see is that it added this new simulation 160 to my list here, and it's now executing, and it'll take about 30 seconds before it finishes. But when it's done, what I'm going to do is actually jump over here into Jupyter Lab, because we've also integrated with Jupyter Lab, and it will do the same thing when I open the server, where it's going to create a clean virtual environment for me and do some package installs. First, I want to make sure that simulation finished. Let's jump over here. There we go. So in this case, I really have two options. I could download the results and continue to work with this locally, or I could pull it into Jupyter Lab and I could work with the results there. We really, going back to the vision of the toolshed, we really wanted to keep this flexible so that you can really work in your IDE of choice. But we have the convenience of that we've put Jupyter Lab integrated into our platform. So I just want to make sure I make note of this. This is simulation 160, the one I just ran, so that when I jump over here into Jupyter Lab, it's already running here. So I'm going to click Open Server, and we'll jump in. All right, so now that I'm in Jupyter Lab, there's a couple things I want to show you. So I'm in my root directory here, and I have a labs.py. So labs.py is a very simple file, which is basically telling where my experiment object is located. So it's within my models folder, which is here. And within my models folder, I have my config file. And so this is a very short running cadCAD model. But I also named my model here. So that's when we saw that the hydroelectric dam model. That's because I actually gave it a name here within my config file. But what I want to show is two things here. So first I want to show actually pulling those results in. And so like I said, that was simulation 160. So what I'm going to do is, I need to let that run for a second there, but I'm going to update this for simulation ID 160. And that's done. And so what I'm using is our SDK, which is going to pull the data out of, you'll see here it's pulling out of S3 on AWS, and it's pulling directly from our database. And because I had opened Jupyter Lab from the platform, it automatically authenticated so that it knows who I am and is able to pull the data that I have permissions to. And then what I did is I installed matplotlib for the packages that we pre-install for you, we don't pre-install some of the graphical packages because there's many options and we want to leave that flexible. And if we just started to load every single one, it would just take longer and longer for this to spin up.
Well, let me just interject real quick, Chris. I do
Sure.
want to clarify on that point. So he's absolutely correct in what he says. We're not pre-installing anything because versions are important to people. We don't want to make any assumptions on which version of Matplotlib or NumPy you're going to be using. But one patch that will be coming in the next week or two is the ability to supply a post-processing or an analytics requirements.txt, which for those of you who are familiar with Python, that's like a file that lists all of the specific versions of packages that you depend on. And if it's in the repo, at the time that you open your Jupyter lab, we will check for it. And if it's there, we will go ahead and install everything that's been specified in that file. But that's not currently in place. That's probably still a week or two out, but that is coming. In the meantime, you'll have to either do what Chris is doing with this inline, like in that cell, he's got a bang, and then he does his pip install. Or you can actually, from the launcher, which is that other tab, you can actually open up the terminal. You've got root access there currently. You can install everything you want. If you're going to install this way, though, I would do pip install with a -- user, just to keep things clean. That tends to work more often than without. So, yeah, that is currently true, what he's saying, but that will be made a little bit nicer in the next week or two. So.
Yes. Thank you, Tyler. Yep, so I went ahead and installed these. I went ahead and ran this, and so my simulation results 160 I threw into a data frame, and you can see the results here. And then now I can call that data frame and run it, and you'll see in a second here a chop pop up. There we go. And now that I have in a data frame, I could do all the post-processing that I want. But this is just a very basic example. This is similar to, I have a Jupyter notebook that gets a little more detail. So I created this, which I actually then, this is what I published onto Twitter, and I'm going to show you how to publish this. But the idea here is that I had this one notebook that has a description, and it has some data. I'm using numbers I found on river flows for the different rivers that contribute to the Nile River. And it asks a very basic question, which is, how long would it take based on a percentage of water being captured, would it fill a reservoir in this dam? So I could set in my initial conditions, what percent, how greedy I want it to be. So I have that here, the reserve percentage, and I have the capacity of the dam. And so basically it's taking those water flows over time, and then at the end it's telling you, okay, well, this is how long it would take. And there again is my data frame. And so it's a very basic model. It could definitely be expanded upon to do other interesting things. But I wanted to publish this and share it like I did on Twitter. And that's another feature that we've added, which is very simple to do. All I need to do is right-click on it, and the first option here is Publish Document. So when I click on that, it asks me, am I sure I want to publish this? So I click yes, I click Publish, and then there we go. So it's saying your document can be found here. I can click on that, and then now you can see an HTML version of that same thing. This is static, so when I share this, it's not like people are going to be able to go in and actually change my model, but I can take the URL and then I can share that with anybody. And this is one of the ways that you're now able to share your work, either as either Jupyter notebooks, or you can also share Markdown files. The other thing that I wanted to point out while we're in Jupyter Lab is we installed one of the extensions to make it very easy to do your commits. So for your commits, you really have two options. You can go to the terminal and do your commits, or you can use the button here where you basically say, okay, which branch do I want to commit to? You can see the history of changes, and then you can see here that I made the change to this, that I could just click the plus sign to commit, put in my commit message, and then when I click the commit button, there's going to be a little, and I can actually just do it because I didn't do that much changes here. So we'll just do demo. It'll tell me commits changed, and then you'll see that there's this little dot next to a cloud, which you have to also do because this is now pushing the change back into GitHub to the repo. And then now that I've done that, it is now live. So that is one of the ways that we publish in a couple of the different features within JupyterLab. I also want to show another publishing feature, but before I do that, I want to check to see if there's any questions at this point.
It's worth noting too that you can actually do all of your work from within here. So not just the post-processing and the publishing work, but as you're developing your model, feel free to just open up in JupyterLab and work on the actual model. You know, commit your changes, push your changes, then switch back to the Labs tab. And as long as you have the correct branch, you should be able to run the simulation, run the simulation again, generate new data, and pull that back into your notebook file where you're using the SDK to do your post-processing. So it's a very self-contained sort of loop, not just on the post-processing side, but also on the model development side.
And to add to that, that's also true for your collaborators. So because I invited all these people to this project, they also are able to download these results, work with the data within JupyterLab, jump in the JupyterLab, and be able to, assist. We could collaborate on the models, which was an important feature for us to include here. It's one of the reasons why it was really important for us to have the permissions outside of GitHub and making it very easy to add more people, because we're really trying to promote the collaborative nature of this line of work, where I want to be able to, invite you in, and if I need help with a model or we're just collaborating with each other, I may be doing a documentation, you're doing the model. This really facilitates, multidisciplinary teams working together to to be able to work together to get the job done for the analysis that you're doing, and including stakeholders. So stakeholders can come in, see the results if they're not necessarily contributing to code. Go ahead, Tyler.
I was just going to say, when you add somebody as a collaborator at the moment, they have full access to your repo, not in GitHub, but if they were to open up your project in JupyterLab, make some changes, they could create branches, they could commit stuff, and they can push it upstream, right? Because the Labs platform is connected through that authorization that you enabled when you first signed up for the account. But the way that we handle that is because we don't want them performing commits and works under your name. So what we do is we tag all of those commits with a special user and some descriptions to let you know in GitHub that those commits were performed by the Labs platform on your behalf, right? So in the future, we will have further restrictions that will allow you to get more granular in what you allow people to do. But right now, just understand that if you give someone access, they don't have access to the GitHub project, but effectively they have push access to your repo through the Labs platform. So just keep that in mind.
The last thing I wanted to show was the other form of publishing that I had mentioned, and there's a couple examples of this. I'm going to jump into this one first. So we have this documentation tab. So for this particular project, this is a model that I was interested in. So all I've done is really written up documentation on, how I was thinking about building this model. And I was able to take that and then publish it. And so we're using mkdocs, and you can see here how I have my table of contents, and it just kind of goes through, and it really walks through where my mindset is on how I would build this model, how it would work, what considerations do I have, initial conditions, and I go into like what experiments I would run, like what would be those conditions for each of those experiments. And the idea here is twofold. One is we're working on creating templates that help people get an idea of where to start when you're modeling. And two, with this publishing feature, this really makes it so that one of the things we can do here is then publish this and seek help or just seek feedback from anybody else who may have interest or has a thought on how you can improve this model, or maybe you got an assumption incorrect. And you have control over access to this. So if you go to the settings tab, you can make this document either private or public. And if it is public, then anybody you share the URL with is going to be able to access it. And the URL stays consistent because it is just using the URL of this documentation tab. If you make it private, then only the people you've invited in the permissions tab will be able to access it. Anybody else will just see a screen that says you do not have permission to view this file. So that is one version of the publishing. The other is to actually build out more, working with more of the features of MKDocs and have it be more of like a doc site. So if I go into something, if I go into this project, in this example, what I've done is I have these examples of what you can do in Markdown to show that we actually support all the different things you can do in Markdown, including equations. So this has a bunch of different mathematical equations because MathJax is supported. But what I also did is I created a doc site by linking some of those other documents within this one place. So for example, here I published this model and then I created a link to it. So now people who then go to this this page can click there and then they'll see this model. Or I have a couple of Markdown files in here. For example, I just showed you this one, so I can click there and there you go. Now this model write-up is all in one place. So this could continue to be expanded. I could just have this be either, maybe it's my portfolio, maybe it is a client project that has a lot of different documents that are necessary for it. But this makes it so that there's that one entry point, and then you can have the user step through the documentation and math specifications for the document. And so I can go into it'll take a second to open up Jupyter Lab. I can show you a little bit of how we did this. While this is opening, is there any questions? Good. Was that going to be a question? Was that Barla? So okay, open server. So you'll see here, one thing I didn't mention before is we're always recloning your repo when you're opening. So you'll see here those last modified seconds ago, because we just did a fresh clone of the repo. So we're making sure we always have the latest and greatest out of your repo. But you'll see here that I have this index file, which is located in my docs folder. So here's my root file. So there's a docs folder, I have a YAML file, and a README. So when you're going to publish, you need to create a docs folder and have an index file in there. And then that index file, with Markdown, you can have the dual mode. So here I've already opened it, but it's just easy to do. While I'm working here, if I wanted to see what the output would look like, I can just go ahead in here and click Show Markdown Preview, so I can see the dual mode if I want. And then when I created these links, I put those into another folder here. So I have two Markdown files here that are being referenced. And I also have my published document here. So I've included the URL to access this. So when I publish this, that's why I had those links there. And then as far as the YAML file is concerned, then there's a couple styling that you can throw into here. This is something I'm still experimenting with, but there's a lot of flexibility here for the formatting options that you want, as far as the style. Like with this one in particular is using the material theme. But yeah, you basically have a lot of different options there on how you would like the look and feel to be.
Yeah, you don't have to include the MK docs though. I tried to make this as UX friendly as possible. So if you want to just get started with a doc site for your particular project, just make sure that you have a docs folder in the root of your project with an index.md, and that's all you need. If you want to throw in the config file, the mkdocs.yaml, you can, but you don't have to have it. We will go ahead and take care of the creation of that with some basic default values, and you can get up and running without having to add anything except for your actual down file. but you do have the ability to customize just about everything with your own custom config if you want to. Now, one thing you wouldn't be able to do, for example, is you can't do your own theme. We have some built-ins. Obviously, Material is installed, and the ones that come out of the box with MKDocs is pre-installed. Outside of that, though, we're always looking for new additions, plugins, things like that to include by default. So if you find yourself using something regularly and you think that it would benefit a lot of people, make sure you let us know and provide that feedback. And then in the future, you won't have to supply that YAML file with custom stuff. We could do it for you out of the box, potentially. So.
That concludes the demo. I'll just check in with the team. Tyler, is there anything else you think I missed that I should cover?
No, I think that's essentially it.
Great. Is there any other questions? Otherwise, that wraps up what I wanted to show today. Other than just making sure you can sign up today. It's just at app.blocksciencelabs.com. And we also have our own Discord server if you have not joined that already, which we intend to use for giving updates, feature releases. You can report bugs, seek help, find other collaborators on your projects. Yeah, and it's a great way to get in contact with us. Otherwise, thank you. Thanks everyone for your time.
Thank you. I also work at BlockScience Labs. I'm product manager, so I wear two hats whenever I'm in the cadCAD community. So yeah, if you have more questions about that, I'm always available. If there's nothing else, we can conclude this. Community call.
I have a quick question.
Yeah.
Excuse me. For what you were going through on as far as using the BlockScience Lab, are y'all going to have a tutorial that goes along with that as far as using Jupyter?
Yeah, there's already recorded tutorials on YouTube.
Okay.
And,
all right. Cool.
Yeah, so
right,
I'm
great.
actually also working on a doc site that is sort of your crash course for everything labs, as well as cadCAD modeling. It includes some demo models, all of which I'm trying to update to get them to be able to be executed on the platform as well, with examples of the post-processing in notebooks and markdown files. But I want this all inside of a sort of consolidated doc site. And that doc site is going to be linked directly from the UI. There's a little help menu up in the upper right-hand corner. You'll be able to click that. There's actually already a whole bunch of resources in there. But as soon as I get this documentation doc site finished and it feels helpful, I'll go ahead and add that link to that menu. And then you'll be able to go there if you want help on learning everything from modeling to using specific features of the Labs platform.
All right, excellent. Thank you.
Mm-hmm.
Good question.
I had a question.
Yeah.
For different features, for such as material, such as alternatives to material, I had some suggestions. One being dyslexic typography, one for people with dyslexia so that they can read the documentation, and another one was having it so that, unless you already have this, so that somebody who has an e-reader that so that they have a program that reads the screen for them so that they can hear it because they're blind or
Right.
or have sight issues. I think that would be a good addition.
Yeah, I think those are both interesting features.
Yeah, I have a whole group of accessibility features on the list for sure.
Yeah. Cool. Anything else? Lovely. NT, I see you talking, but I'm not hearing anything, so I'll just sort of take over emceeing. So thank you so much, everyone. We will be posting recording of this on the cadCAD YouTube page, and that'll be shared here in the Discord. We'll also make the presentations that were shown today shared in the Discord as well. Thank you, everyone.
Thanks, guys.
Thank you. Bye.